In this session, we're going to talk about RDS and the various components of RDS. This will be a three-part session, so we encourage you to take a look through each one and familiarize yourself with what is one of the key technologies MSPs use to bring their customers to Azure through the use of virtual desktops. Enjoy the sessions.
Okay, so today we are going to talk about RDS and various components of RDS. This may take us 1 or 2 sessions, most likely. So let's get started by talking about the RDS architecture and the various roles associated with the remote desktop services. So just a bit of history. Most of you probably already know this, but I'll mention it anyway. RDS is what's used to be known as terminal services. It evolves quite a bit with each successive release of Windows Server that comes out. Started out, and from what I recall, in Windows NT, there was a special version of Windows that had terminal services as part of it. And then in Windows 2000, RDS became sort of a built-in function of Windows Server. Licensing for it was actually free if you were connecting from a Windows 2000 or above client OS. The licenses were free. Then Windows 2003 added some load balancing capabilities, and they started charging for licensing once again. And then in 2008, Windows Server 2008, Terminal Services was renamed to Remote Desktop Services, and it became more of a role-based architecture, and that evolved furthermore in 2012. 2016 added a bit of functionality, but for the most part, 2012, 2016, and it looks like 2019 are going to be similar from an architecture standpoint. Citrix used to be a very important add-on on top of Windows NT, Windows NT 4, and on top of Windows 2000, but a lot of the core functionality that Citrix provided was then built into Windows natively. So as newer versions of Windows came out, there was fewer things that Citrix did at the core. There's still a lot of add-ons, like the display protocol is better, arguably better than the native RDP, etc. But for the most part, we're seeing people moving away from Citrix and moving towards an RDS deployment. Okay, so in RDS deployment, again, conceptually similar to what we would see with a VMware Horizon deployment, where we use dedicated VMs, again, and we're going to refer to that as VDI, where every user gets a dedicated VM as their desktop. You have 2 components to it. You have more than 2 components, but the easiest way to think about it, there's the control plane, and the control plane is what determines who's coming in, whose connection is coming in, authenticating that connection, and determining what desktop resource to place that connection on. So if you think about the VMware Horizon world, we have our security gateway that sits in the DMZ. We have our connection manager, which maintains the inventory of the virtual infrastructure, and all of the entitlements and assignments are done there. So a connection comes in over PCO-IP from the Horizon client. It gets authenticated on Connection Manager. Connection Manager determines which VM it belongs on, and then the security gateway does the actual tunneling of that traffic once Connection Manager authenticates it. Okay, so again, conceptually think of the desktop resources being independent of the control plane. In the RDS world, things work similarly. You have your control plane, which consists of things like license server, connection broker, gateway, web, Active Directory, etc. And then you have your actual session hosts. And those session hosts can either be dedicated to individual users, in which case we'll refer to them as VDI, or they could be shared by multiple concurrent users, in which case we'll refer to those users as RDS. Again, that's just a terminology we use internally. It may not be necessarily consistent with what you see in documentation, but when we talk about a VDI user, that means a user has a dedicated VM. We talk about an RDS user, that user is sharing a session host with other users. Okay, so that's kind of the high-level overview of how this works. Now let's dig into the architecture a little bit. So what are the roles in RDS? So publicly facing roles include remote desktop, RD is for remote desktop gateway, and remote desktop web. The remote desktop web is a page you can go to where you can authenticate. And when you authenticate, it presents you with anything that's published to you. So in the VMware world and the Horizon world, this is the equivalent of an entitlement. When you entitle a user to, let's say, a desktop pool, if you entitle one user to multiple desktop pools, then they will see both of them inside of their Horizon client. Similarly, when they go to an RD web page, this RD web page will present them with what's available to them and what they're entitled to. So let's look at an example. Let's look at rds5009.nerdio.net. All right, so this is the RD web page. We can log in here. Let's say Nerdio AIT admin. This is our demo account. Okay, so once we log in, we'll see that the user is entitled to these two collections. It's a very basic looking page. And when I click on one of these collections, what you'll notice is it downloads an RDP file on the bottom there. If we click on that RDP file, it actually happens to be non-SSL signed. So it gives me this little warning at the top. And it shows you what this RDP file will connect me to. It will connect me to such and such remote computer through such and such gateway. And we'll talk about all those components in a minute. But the point is I click here, I type in my credentials, both username and password, and the connection actually gets launched using the remote desktop client, which everyone is familiar with, which is this guy, right? So the remote desktop connection client. Okay, if you had applications, so remote apps could also be published in RDS, those would also show up alongside here. So RD Web doesn't have a ton of use other than providing users with their RDP file. There is another way to access RD Web, and that is called an RDS, I think it's called a stream, where you can use this thing in the newer versions of Windows called remote desktop apps and desktop connections. You can actually point this at a particular URL. So in this case, it's going to be something like rds5009.nerdio.net/rdweb. And I'm not sure why it's not working, but you get the concept. You'll basically see all of your connections inside of this screen, and they may also show up in your start menu kind of natively. But from an RDP or remote desktop connection access standpoint, RD Web is what gives you that RDP file for either a desktop or a remote app. So in the Nerdio implementation, instead of sending users to RD Web, we've chosen to implement the process of creating the RDP files ourselves. So as you all are all familiar with, if you go under users inside of Nerdio, there is a generate RDP file. And this has a few advantages. First of all, you get to configure the file to customize it. Maybe you do want printer redirection. Maybe you don't want printer redirection. You can choose whether copy and paste is enabled. And you can also select to publish either the whole desktop or a specific application. If you click on remote app, it's actually going to enumerate everything that's installed on the desktop that this user is assigned to, and will allow you to select an application from a list. And then when you click confirm, what this does is it actually builds that RDP file per these instructions, and it signs it with our SSL certificate. So when you download a file from NAP, you get slightly better naming. So it shows you who the user is with the machine name in parentheses. And then when you click on it, it becomes a signed file. So you can see here, no longer says unknown publisher. It's now signed by Nerdio. When you click on it, it has all these things pre-configured, including the username. So the only thing the user has to type in is the password. So the reason I'm telling you all this is because for purposes of the Nerdio NFA deployments, we don't really leverage the RD Web to be used in this particular fashion because NAP has its own more robust functionality. Okay. The other thing that RD Web does in the newest version is there is now something called the RD Web Client. An RD Web Client is an HTML5 interface into your published apps and desktop. So instead of going to RD Web, I have something installed called Web Client. I now go to our Web Client. When I log in, same credentials. You see the login screen looks a little bit different. Okay, I get what looks to be the same set of selections, but now instead of when I click on it, getting an RDP file, this is going to launch my session right inside of the browser. So this is the equivalent of the Horizon HTML client that allows you to access it via web browser. Any HTML5 browser will work. This is a pretty new feature. It's still not fully functional, and it needs to be configured on each deployment. And when we deploy a collection, then the collection gets this particular feature enabled. I'm not sure why it's not working for this pool, but let's try this guy. So that's the RD Web role. It sits in the DMZ. It's publicly accessible. It allows HTTPS, support 443 connections to come through. Okay, and there we go. We have our HTML-based window here. Okay, so let's go back and look at the infrastructure one more time. Okay, so we talked about RD Web. So RD Web is the first thing the users hit if they're using a web interface. They can use the RDP file that they download from either RD Web or from the NAP, and they do not need the RD Web role. Now, RD Web is a Windows role that does not need its own machine necessarily. It could be running on the same VM. In this case, the illustration is showing you that the same VM is running both the RD Web role and the RD Gateway role. Now, the Gateway role is also a publicly facing role, and it's actually critical in the connection path because without it, you cannot connect to your VDI or RDS desktops that sit inside of the LAN. And the reason is because RD Gateway is the security gateway equivalent in the VMware world, where you're actually tunneling the connections from the public world into the LAN. Okay, so let's take a look under servers in Nerdio. You'll see there is this server called RDGW01, which is the RDS gateway. It sits in the DMZ, and it has a certain set of firewall rules that allow port 443 TCP from the outside, which is how you authenticate with it. And then it allows port 3391 UDP, which is how you securely tunnel the RDP traffic. So the purpose of RD Gateway is to encrypt and route traffic from the public internet into the LAN. In the absence of RD Gateway, you would have to open port 3389, which is the default RDP port, to a specific connection broker or RDS session host. But that protocol, the RDP protocol, is natively non-encrypted. So there would be an unencrypted connection that people would constantly be trying to brute force connect to. So putting RD Gateway is absolutely the best security practice, and we do that in Nerdio by placing an RD Gateway here in the DMZ and then allowing it to connect into the LAN for authentication reasons and to actually get to the desktop resources. So then let's move on to the other roles. So, the other really critical component of all this is Active Directory. So Active Directory is what is authenticating everything. So the RD Gateway authenticates users against Active Directory before even passing the connection through. Obviously, RD Web is authenticating against Active Directory to decide what to present to the user on the screen. And then once the RD Gateway passes a connection through to connection broker or an individual session host, that authenticates against Active Directory to kind of decide whether to allow that user to come in or not. So Active Directory is obviously a critical component that all of the RDS roles must be able to communicate with. Okay, so that one is pretty easy. Then the other sort of easy role is called RD Licensing Server. The RD, again, all of these are roles. They could technically be installed on a single VM, but because of the nature of these roles and you know their resource demands or their security requirements, it's best to group them in some fashion like this, if not split them into individual VMs or even clusters of VMs if the environment is really large. So in Nerdio, RD Gateway, RD Web are in the same VM. RD License Server is on the domain controller. So this VM here that's labeled as AD in the Nerdio environment actually has the RD License Server installed on it. RD License Server is where you register the RDS license pack that you buy from Microsoft, either through software subscriptions, which, you know, we'll talk about licensing, how RDS licensing works either later in the session or next session. But this role, what it simply does is it receives connections from the RDS session hosts and tells them whether they have a license to license a particular user that's connecting. There's a per user licensing model and a per device licensing model, but it is a mandatory role. Without it, these servers will fall into an unlicensed grace period, which I don't remember if it's 30 days or 120 days. There's some period of time while you can install and run RDS session hosts without them seeing a license server, but eventually in order to continue working, that role is mandatory as well as AD. Okay, so RD Gateway is mandatory for security. RD Web is optional if you want either HTML client or a portal to build RDP files for you. AD is mandatory, license server is mandatory. The session hosts, well, let's leave session hosts till the end. The next component is called RD Connection Broker. Okay, so RD Connection Broker is a role that generally sits on a internal VM, and the connection broker is what determines who goes where, right? So RD Web gives you the connection file, RD Gateway captures your connection, authenticates you, encrypts your connection, and then forwards your connection to the connection broker. And the connection broker then sees, okay, now, you know, John Smith is coming in. What is John Smith entitled to? And John Smith may be entitled to individual session hosts or a collection of session hosts or specific applications on a collection of session hosts. So the RD connection broker is going to actually route that connection. So the RDP file of somebody who's connecting through something that has a connection broker in place is going to include the connection broker address. Let me give you an example. So let's go to a user that is a member of a collection. So you can see here, Angie Accounting is member of this collection, RDS collection B, whereas Chat CEO is an RDS user on this session host directly, and Andy is a VDI user of this VDI machine. So first, let's see what the connection looks like for Angie. So we're going to generate an RDP file and open it. And what you'll notice is that we are all routing through the same RD Gateway server, but I'm going to this RD collection b.nerdio.net, which if you resolve this IP address internally, it's going to point to the connection broker server. So if someone is coming into collection A, it will be listed as collection A, but the IP of it will actually be pointing at that same connection broker, and the connection broker is going to route the connection appropriately. Now, connection broker is optional, and it's actually not deployed by default with a Nerdio for Azure provisioning. So the way Nerdio for Azure provisioning comes out is it comes out by default with a single session host called RDSHO1, and all the users that are RDS users are assigned to that single session host as opposed to collections which don't exist by default. So here's what that looks like. If we click on the generate RDP file, download it, open it up, again, we'll see the same gateway server, but you see the computer name is the specific RDS session host. So there are fewer hops that I have to go through. I always have to go through the RD gateway to get encrypted, but then right from RD gateway, it's going to forward my connection to the session host. Whereas in the collection scenario, I'm going to go from RD gateway to the connection broker, from the connection broker to one of the session hosts inside of a particular collection. Let's think about a typical simple environment, right? So again, the reason I gave you the history of terminal services in RDS is if you think to the world pre-2012, there was no such thing as connection broker. You basically assigned users to a specific session host, and multiple users were connecting to that session host. The advantage is when they're connecting to the same session host time and time again, you don't have to worry about managing their profile because they're always on the same VM. So their profile could stay in C users. You can redirect their data for protection reasons, but any of their configuration can stay in place. You also have a simpler environment. You don't have this chain of connectivity where any one component can fail, including the connection broker. If it's in place, right? If it fails, then nobody can get through to the session hosts that are behind it. If you eliminate it from the connection chain, then everyone is going directly to session host. So you have simpler, lighter infrastructure. Also, because you can use native profiles, meaning profiles that stay inside of the C users folder, things like OneDrive, Outlook, caching, search index, all of those things that sort of require local access, and we're all familiar with linked clones, some of those challenges, all of those go away. So it's a simpler, easier way to configure things. The big drawbacks is you have users pinned to specific session hosts. So if a session host goes down, you don't have another one that can take over that workload. All of the users who are assigned to that session host are now no longer able to work until that session host is brought back online, okay? So there is no load balancing and there isn't any redundancy when you're dealing with a single user to session host assignment. With RDS collections, the concept is that you have a collection or a group of identically configured session hosts, and these session hosts sit behind the connection broker and get packaged in what's called an RDS collection. And then when the user connects through the connection broker using the load balancing algorithm that you can configure, right? Whether it's affinity based or maybe CPU based or whatever the case may be, it determines where to place your particular desktop session. And then if a host inside of that collection becomes unavailable, let's say it needs to be taken down for maintenance or updated or it crashes, then users can log back in with the exact same configuration information and be able to connect to another host in a session that's going to look identical to what they just saw before. So very similar conceptually to the linked clone approach, where if you don't have users assigned one-to-one to individual desktops, and they are assigned to a pool of floating desktops, then they can get assigned to any desktop that's available. So it gives them more redundancy and availability, but as we all know, leads to some really major management challenges because of this whole profile situation where you no longer are able to use local native profiles that are stored in C users, because if you connect to server A today and then server B tomorrow, your configuration may look different and out of sync, and that's not okay, right? So there are multiple ways to address it. Windows has something native called roaming profiles, which we know doesn't work well. And then in version 2012, I believe, of RDS, they introduced the concept of UPD, or user profile disks. And the concept here is when a RDS session gets established, a VHD file, which is a packaged virtual disk file that is stored on a file server somewhere, independent of the individual session host in your RDS collection, that UPD file gets mounted as your profile, and any changes you make get saved there, which means they get redirected off to a file server. That when the session gets disconnected, it tears down, disconnects that file, you log back in. Even if you're going into another session host, you are going to be able to see the same profile configuration since it just mounts the very same VHD file. Okay, so RDS collections are appropriate when you want to have lots of users that have very similar or identical configurations, so they can switch from one VM to the other pretty seamlessly. The drawback to RDS collection is obviously you have this connection broker that's an extra VM, extra role, extra complexity, but also not having your profile be native creates some limitations. Sometimes there's just bugs, things like the VHD file doesn't get properly unmounted, or it may be mounted to session host A, but then you get reconnected and the connection broker decides to place you as session host B, and your VHD file is exclusively locked by session host A, so you can't get your profile. So that's a potential problem. And the other problem is things like indexing and things like OneDrive local caches don't work with UPDs because they're able to detect that you're redirecting the profile over the network, and they will give you an error when you install the application like a OneDrive client that it doesn't support network-based profiles. So there are some real limitations with collections, but they do give you more scalability and ability to horizontally scale out. Whereas with session hosts, if you want to grow the capacity of a particular individual session host that users are assigned to, you have to scale up, right? With scaling up means you add resources to an individual VM. Scaling out means you're adding additional VMs into a group of other VMs, and then you're using some mechanism of distributing users across those VMs. Microsoft has announced that they've purchased a company called FS Logics, which is a competitor to what's the name? Liquidware, I believe, Profile Unity makers, and a few other companies that make similar products. Microsoft just recently, within the last month or so, purchased FS Logics, and in the next version of their Windows Virtual Desktop, which is going to be an alternative to RDS that we'll discuss in the future session, they are going to integrate that product that's going to be part of the deployment. And the nice thing about FS Logics, and the reason Microsoft purchased them, is they integrate they mount the profile at such a low level in the operating system that none of the applications are able to distinguish that this is not a native profile. So it eliminates all of the limitations, the indexing and the profiles and the OneDrive and all of that stuff just natively works, because as far as any applications are concerned, to them it looks like it's a native profile.